Okay, hopefully you've had time to work on the warm-up. So the warm-up says, in which graph is 2, -5 a solution to the system? And then it says, is 2, -3 also a solution to the graph selected? So we're looking for two things. We're looking to see if this point is definitely a solution, and then we need to answer, is this a solution to that graph also? It says name the ordered pair that is not a solution to your graph that you choose. So first we've got to figure out where is 2, -5. So 2, -5 would be right here. So I'm going to go ahead and put that point on each one of these graphs so that we can then determine which one it works on. You probably already see it. Okay, so on this one it's definitely not a solution. On B, it's definitely not a solution. C is not a solution. It is a solution on D because this point is inside the gray area. And then it also says, is 2, -3 also a solution? So 2, -3 is this point right here, and it's not touching the line. It's just right next to it. So that is not a solution. So no. 2, -3 is not a solution. Okay? So then it says name an ordered pair that is not a solution on the graph you choose. Well, if we do 4, 0, that is not a solution. So I'm going to write it next to the question. So 4, 0 would be not a solution either. Okay? Alright, so hopefully you did good on the homework for last night and you kind of feel more comfortable with the calculator. We're going to be doing the same thing today. We're just going to throw in some application problems. So it's word problems, but it's fine because they're the exact same thing that we did yesterday. So first one says carbon dioxide is a greenhouse gas that's emitted into the atmosphere from a variety of artificial and natural sources, including automobiles. The table below shows the concentration of carbon dioxide, CO2, in the atmosphere measured in parts per million. This is how you abbreviate it. It's ppm. When entering your data, you're going to use x equals 0 to represent 1970. Do you see where they get the 0 from? So when we start, we're going to do 1976 as 6, and 1978 as 8. 1980 is going to be what? Now these don't necessarily go up by 1. This was 6, this was 8, this is 10, 82, this is 12. This is years since 1970, remember. So this is 14, 16, 18, 20, 22, 24, and 26. So these are your x values that you're going to use. Okay, so when you plug this in the calculator, you're going to make sure that you're in 2 variable, so 2 var, clear all the data that was already in there from maybe you doing your homework last night, and then go ahead and put that in. So go ahead and pause, put in your data. When you're ready, push play. So it says create a scatter plot. Well, before we do anything, we need to kind of label this scatter plot. So CO2 in parts per million was my y-axis, and I'm going to write an arrow for my x-axis because it's kind of close there. Hopefully yours isn't as close. Numbers of years since what, 1970? Okay, so that's your x-axis. Sorry I couldn't fit it underneath there, but hopefully you can. Alright, so we already did A. We have, well, we got to do our data points. So your data points start at 6, and then you go up to 332. So you put a dot there. And then 8 is going to be 335. So that's just a little bit above. Hopefully you can tell what these are counting by. These are counting by 2s. So 335 is going to be a little bit above 334. And then 10 is going to be 338, which is almost 340, so it's right in the middle there. Remember, any even number should be on an actual line. 12 is going to be 41, which is just barely above 340. 14 is 344. right on the dot. 16 is 346. Still go up just a little bit. 18 is 350. 20 is 354. 22 is 356. 24 is 358. And then the last one is 362. So that's the very top one up there. Okay, so that's what our data looks like. It looks like it's pretty linear. You could almost make a completely straight line. There's a little bit of a bump in it, so that's okay. All right, so it says, after you use the calculator, find the line of the best fit. Does the scatter plot look linear? Well, yes. We just said that. Looks pretty linear to me. So your equation that you found should have been y equals 1.49x plus 323.05. Okay. I always go ahead and put my r value just so that I can see what it is. So 0.99. So that's definitely a strong positive. Strong positive correlation there. And I would probably guess that it's a strong positive because it looks like it almost makes a straight line. And remember, the closer to 1 your R value is, or your correlation coefficient, then the closer to a straight line it makes. So it says estimate the number of parts per million in the atmosphere in 2008. Well, 2008 has been how many years since 1970? So X was 0 in 1970. So X is going to be 38 in 2008. Okay, so we're just going to plug in 38. So Y equals 1.49 times 38 plus 323.05. Use your calculator, and you get Y equals 379.67, and it says estimate the number. So I'm just going to estimate it and say that we're just going to round there. And you round normally with parts per million because you're not talking about people. So 380 parts per million is what I would say my answer is. Okay, so anytime it says estimate, it's totally fine to round. Okay, next one. It says on Tuesday, May 10th, 2015, 17-year-old won the boys' shot put gold medal for the 4th consecutive year. His winning throw was 16.43 meters. A shot put throws the ball at an incline of 45 degrees to the horizontal. So that means 45 degrees basically above the ground. The following data represents the approximate heights for the ball thrown by the shot putter as he travels a distance in X meters horizontally. So plot the data the graph provided. So first we're going to plot this. Always label. So this is height. And then on the x-axis it's going to be distance. Okay. And once you plot this, it should be kind of easy. 7 is going to be in between, 0 and 10. This is 0 here. So we're going to move a little bit closer to 10. We're going to go up to 8. So it's a little bit more than halfway. And then 20 is 15, which is a little bit less than 16. 30 or 33, so a little bit more than 33 is 24. 47, so it's closer to 50, and 26. So right on that one. And then it starts to go back down. So 60 is going to be 24. And then 67, which is almost 70, is 21, which is just a little bit above 20. So you can kind of tell that if you throw a ball, it's going to kind of start and it's going to go up and it's going to peak, and then gravity's going to take hold and it's going to go back down. So that makes sense that this graph is going to make that shape just because we know what a ball does when you throw it. It's going to eventually come back down. So does this graph look linear? And we're going to say no, definitely not, because it's not in a straight line. This one actually looks more like an exponential model. So let's pretend that it did not let's pretend we didn't do the scatter plot and we had no idea. So we're going to find the linear model that represents this data. So you're going to use these as your x values and these as your y values and put them in your calculator. You're going to use your variable 2, plug them in the calculator, do your stat var, find your a, b, and r, and then you're going to write the equation. So pause it, go ahead and put those in, and then push play when you're ready. So the equation that you probably found was y equals 0.23 x plus 10.82. Okay? So we should all get the exact same one if we plugged in the data right. If you didn't get the same equation that we've been getting, then you're probably putting your data in a little bit wrong. It says, would the height of the ball be if it travels 80 meters? So if it travels 80 meters, meters is our distance, okay? So height in meters is different than distance in meters. So it says it travels 80 meters. Not that it is 80 meters high, we want to know our height. Okay, so that's our x. So x is going to be 80, so what you can do, I'm going to erase this so I have room. So y equals 0.23 times 80, plugging that in, plus 10.82. And when you calculate that, you get y equals 29.22. So this is how high the ball is after it's traveled 80 meters. And then it says interpret the y-intercept, so solve for x. Got to solve for x on this one. Does the value make sense? And I know you're probably close to the bottom there, so I'll try to start way over here. 0.23 x plus 10.82. You're going to plug in 0. So you're going to plug in 0 for x. So y equals 0.23 times 0 plus 10.82. Well, you'll probably notice that you're just left with your 10.82, which is your y-intercept. Okay, so I've got y equals 10.82. Okay, so does this make sense is what it's asking. So it's saying when you throw it a distance of 0, okay, you didn't throw it at all, you threw it a distance of 0, it goes 10.82 meters high. Okay, so does that make sense? You have to think about it. 10.82 meters is a good bit. So it doesn't make sense for that to happen because this is not really a linear model. You got to remember that. It's an exponential. So we treated it like it was a linear model, and since this does not make sense, then we know that this is not a good fit. So no, it does not. Does not make sense, so we know that it's not a linear model. Okay. However, it would, if it was in feet necessarily, then I would say that it would probably be feasible for it to be maybe 6 feet off the ground, because how tall is the person throwing it? You're definitely not throwing it from 0. You're throwing it from some height, just not 10.82 meters, because that's tall. Okay, number 3, local ice cream shop wants to see the relationship between the number of weeks after the start of winter and the number of customers. So we're first going to plot the points, and we're going to do the best fit line. Find the correlation coefficient also. So this is the number on our y-axis, number of customers. And then the number of weeks after winter. Okay, So then it's given us the data points there. So 1 is 200, so we're just going to literally plot these. 2 is 175. 4 is 175. 5 is 150. 6 is 125. And 8 is 100. So right on the dot, right there. All right, so we can look at this and we can see that there's definitely a linear regression happening somehow. It looks like it's going to be in the negative, so I would predict that my correlation coefficient is probably going to be negative. Okay, pause the video, go ahead and use these as your x and these as your y, and put those in your calculator and find the equation. All right, the equation you should have gotten was y equals negative 13.75 x plus 213.75. Notice that it's a negative slope. Should it be a negative slope? Yes, because it looks like it's going down. And then my correlation coefficient was a negative 0.96. So that also tells me that it's a negative correlation. So what does the R mean in this content? So it means there is a strong negative correlation. I'm abbreviating, negative correlation between weeks after winter and customers. Okay, I kind of had to squeeze it in there. So what it says is there is a strong negative correlation between the weeks after winter and customers. So a strong negative because it is close to 1, but it's close to negative 1, so it's got to be negative. So it says, using the formula, find the estimate number of customers if it is 3 weeks after winter. Well, weeks was our x, so we're going to make sure that we plug in 3 for x. So y equals negative 13.75 times 3 plus the 213.75. And when you calculate that, you get y equals 172.5. There again, we're talking about people, so we can't have 0.5 of a person. So it's 172 customers. 172 customers is your answer. All right, number 4 says the National Honor Society wants to find the relationship between the number of minutes studied and the grade on their quiz. So our x-axis is time studied, and that's measured in minutes. And then on our y-axis, this is our quiz grade. And it is a percent. So I'm going to write a little percent there so that we'll know. Okay. So go ahead and put this in the calculator, pause it, come back when you're ready. So you should have used these for your x and these for your y. You'll get the equation y equals 0.59 x plus 50.53. Your correlation coefficient is 0.86. And I'm not going to take the time to put all the dots up here, but you should see that it kind of curves. So I don't know if it's going to be really close, and this tells me that it's not really close to a straight line. It probably looks like it's going up, but it might be a little bit scattered out, so that's okay. So I would still consider that as strong. So I would say there is a strong positive correlation between, and this is how you're going to do it each time, like you did in the one before it, between what? Between what we're studying, so time studied, and our score. So that's kind of a no-brainer. The longer you study, the better your test grades are going to be. Okay, Using the formula, predict the quiz grade for someone who studied for 40 minutes. Remember, time studied is our x-axis. So we're going to plug that in for x. So y equals 0.59 times 40 plus 50.53. And then you get y equals 74.13. So since we're talking about percentages, I would just round that to 74%. Okay? 74% is what they would get on their grade. So on this next one, you're going to find the equation of the best fit line from the scattered plot, and then you're going to find the correlation coefficient. So what you're doing is you're filling in the table. You're going to fill in this table based on your points. So what I do is I just go literally from left to right, and I just get all my x's. So this x is 1, and for this point, my y is going to be 8. So that's 1, 8. Okay? And I like to kind of go over my dots or put a check mark next to them or something so that you'll know exactly what's going on. So that one's going to be 110, and then 29, 37, 65. So take a minute and do this. 73, 94, and 10-1. Okay, so make sure that you've gotten all of them. I'll mark all mine. You're going to use this chart and you're going to fill in your calculator, and you're actually going to look for the correlation coefficient and your line. So go ahead and do that, and then you're going to try example 6 on your own. So go ahead and pause, finish example 5, do example 6, and then when you come out back, we'll go over it. So you should have gotten y equals negative 0.83 x plus 9.91, and it's negative 0.95. That's what your correlation coefficient is. So that's pretty strong. It's a strong negative. Over on the other side, when you go through and you do your table, you've got 2, 2, 4, 3, 5, 8, 7, 7, 10, 11, and 12, 12. Okay? And when you plug that in the calculator, because you should have already done this, you've got y equals 1.01 x plus 0.41. And your correlation coefficient is 0.94. So there again, it's pretty strong positive. Okay? And again, don't forget that these are going to be online on my website under the Algebra tab. And you can always ask Miss Vance, Miss Benson, or Miss Brown for extra help.